stack after the world transformations have been applied to the object. That means after the transformation matrix, position, rotation, and scale stored in the matrix strip value in the transform property has been applied to the incoming mesh, which is normally calculated in local space. If you would like to take a look at the vertex in local space, we could say get vert from the mesh property of the current node and index 1, and the result is minus 50, minus 50, 0, which is the offset in local space from the pivot point that is currently at 50, 50, 0. The mesh property results in the tri-mesh. If you would take a look at the result returned, it's a tri-mesh which represents the mesh before the world transformations have been applied. That means that all the vertices in this tri-mesh value are still in object space. We can convert between these two types of coordinates. For example, if we would like to know the world coordinates of a local vertex, we could multiply by the transformation matrix of the current node, and the result would be 0, 0, 0. Similarly, if we would like to know the local coordinates of a vertex that has already been transformed into world space, we can take the inverse of the transformation matrix, multiply the vertex by the inverse, and get the local coordinates. If we would enable the bend modifier on the stack, all the vertices that we have are going to be modified, which means that in the case of the get vert, we would get the position of the vertex in world space, including the modification applied by the bend modifier. Similar, the get vert from the mesh property is going to return a modified vertex position which doesn't have the node transformation applied yet, but while in object space it still reflects the top of the stack just before the node transformations. If you would like to know the local coordinate of the vertex before the modifier stack has been evaluated, that means minus all the modifiers and minus the node transformation, we could say get vert from the selected object's base object, which we assume that is an editable mesh, otherwise we wouldn't be able to access the properties correctly. We take the mesh property of the base object and access the vertex 1. Its coordinate is minus 50, minus 50, 0 in local space because the bend modifier hasn't been applied yet at this level. The only way to access the final vertex position after both the modifier evaluation, node transformations, position, rotation, scale using the transformation matrix, and space swaps, which change vertex positions after the node has been placed in space, we would have to use the snapshot as mesh function. For example, get vert from the snapshot as mesh result of the selected node and vertex index 1 would result in a position which takes into account the bend modifier on the modifier stack, the node transformation, and the noise applied on top. Without the noise, the result would be the same as before. Evaluating the get vert from the top of the modifier stack, including the node transformation but without the space swaps, would still result in the old value. Getting the mesh from top of the modifier stack before node transformations and space swaps wouldn't be affected by the space swap, and obviously the value from the base object mesh doesn't take into account anything else above the base editable mesh object. It's important to note that since the transformation, the node transformation, is being applied on top of the object but before the space warps, it has an effect on the space warps. The whole meaning of space warps is to be able to create a field in world space where, when the object is moving through this space, this change of position, rotation, and scale affects the transformation of its vertices by the space warp. As you can see, when we move the object through the noise field created by the space warp, the vertices are being changed.